Uniform circular motion. An object in uniform circular motion describes the circular path at a constant speed. The speed of the object remains constant at all times in uniform circular motion. But even though the speed stays constant, the velocity changes in direction. So, for example, the instantaneous direction of motion at this point is given by the tangent to the circle at this point. And at any other position or location, again, the instantaneous velocity at this location is given by the tangent to the circle at this point. So even though these velocity vectors are the same in magnitude, they vary in direction. So this velocity is therefore referred to as the tangential velocity being directed along the tangent. You can find the magnitude of this tangential velocity, which is the tangential speed, by simply applying the distance over time formula for speed. So if you look at the object making one full revolution, the distance traveled in one full revolution is the circumference, which is 2 pi r, where r represents the radius of the circle, and divided by t, where t represents exactly the time of one complete revolution. So this t is referred to as the time period, being the time of one lap. So now, because the velocity is changing continuously, even though only in direction, there must be an acceleration acting on any object in uniform circular motion. So uniform circular motion is an example of accelerated motion. The role of this acceleration is unique because this acceleration only changes the direction of motion without changing the speed of the particle. This acceleration is referred to as the centripetal acceleration. Recalling Newton's first law, every object has the tendency to stay put in rest or in uniform motion, whatever it was doing previously in the absence of an external force. So the object's natural tendency is to move along a straight line. So if you want it to curve and take a circular path at every instant, you must apply a force or cause an acceleration that causes it to turn. So that acceleration is what we call as the centripetal acceleration, and the force responsible for this acceleration is called as the centripetal force. So any object in uniform circular motion, there must be some force in the system that is pulling it towards the center, which is causing it to deviate from its tangential path and keep it in circular motion. So different systems have different forces act as the centripetal force. So if you have, say, if you're looking at the earth rotating around the sun, what will be the centripetal force? It will be the gravitational force of attraction that is going to act as the centripetal force. If you look at the microsystem where there is the nucleus, which has positive protons and neutrons, and then the electrons revolving around in circular orbits, here the electrostatic force of attraction is your centripetal force. If you look at the case of an object tied to a string, a very light object tied to a string and whirled in a horizontal circle, the tension is your centripetal force. In amusement park, there is this ride where there is a revolving drum, and the person, let's say we have a cut out of this drum through which you can see. So the person stands with its back to the wall, and the drum starts rotating, and as the drum picks up speed, the platform from underneath the person is removed, so the person is just plastered to the wall. So what is the centripetal force in this case? We always have to look for the force that is pulling the object towards the center of the circle, right? So in this case, the normal force which the drum exerts on the person, the normal force is your centripetal force.